कैसे हैं आप? उम्मीद करते हैं कि स्वस्थ होंगे, मस्त होंगे। और आज आपके लिए नया टॉपिक और स्टार्ट करेंगे। चैप्टर नंबर 8, स्टडी ऑफ कंपाउंड हाइड्रोजन क्लोराइड। ओके, एंड चैप्टर नंबर 8, स्टडी ऑफ कंपाउंड हाइड्रोजन क्लोराइड. What is the formula of the hydrogen chloride? You know very well. Molecular formula of hydrogen chloride is HCl, and the molecular mass of hydrogen chloride, atomic mass of hydrogen 1, and the atomic mass of chlorine 35.5, and the total mass of HCl 36.5. Okay, and you know very well which type of bond found in between the HCl, means H and Cl, that is covalent bond. You know very well, covalent bond is formed by the mutual sharing of electron. When the single pair of electron shared, then single covalent bond will be formed. So which type of the bond formed between the H and Cl? Covalent bond. And you know very well, covalent bond are also two types. One is the polar covalent bond and the second is a non-polar covalent bond. So it is a which type of bond? It is polar covalent bond. Polar covalent bond. It is electron of the hydrogen and it is electron of Cl. By the mutual sharing of single electron, means that it share one another and form a what? Covalent bond, polar bond. And it is a what? Lewis structure of HCl. Lewis structure of HCl. Firstly, Glauber prepared the acid in the 1648 by heating NaCl plus H2SO4. And who prepared the firstly HCl? Glauber. In which year? 1648. And the Joseph Priestley prepared the gas from the sea salt in the pure form, and Lavoisier named it the muriatic acid. And after that, the Glauber, who prepared the HCl from the salt, sea salt, who? Lavoisier, and the Lavoisier named it what? Muriatic acid. Mean the Joseph Priestley prepared the HCl, after that the Glauber, and the HCl called the what? Lavoisier named it acid called the muriatic acid. And after that the Joseph Priestley, Davy in 1810 named it as a hydrochloric acid. Lavoisier said that HCl2 muriatic acid, but the Davy in the 1810 named as a hydrochloric acid. Clear, everyone? And you know very well, your next topic is occurrence of HCl. You know, HCl are found in the free form and as well as combined form. Means HCl found in the first free state and also found in the combined state. First we will discuss about the free state, occurrence of HCl in free state. First, HCl gas HCl gas occurs in free state in volcanic emission, and also found HCl in the gastric juice. You know very well, in our stomach found the three types of the gastric juice: HCl, pepsin, and the mucus. And the HCl also found in the our stomach. It is considered as occurs as a free state. And next is your in combined state. And in combined state, HCl are found in mineral such as rock salt. And you know very well, rock salt is found in the form of NaCl, means common salt are found in rock in the form of rock salt. Okay, and horn silver, AgCl, and Sylvine, KCl. So all are the in all salt found what? HCl. Okay. Get on the next topic. Next topic is your general preparation of HCl gas. General preparation of HCl gas. First, bisynthesis reaction. Bisynthesis reaction, it is also called the direct combination reaction. Which type of reaction? Direct combination reaction. When hydrogen gas is treated with the chlorine in diffuse light, then it will form HCl gas, means hydrochloric acid. Means when hydrogen gas is treated with chlorine gas in the presence of diffuse light, then it will form hydrochloric acid. And this reaction is very explosive in the direct sunlight. Okay, but it is negligible in the dark. So keep in mind, when hydrogen and chlorine react in the direct sunlight, so this reaction will be very explosively. Okay, that's why this reaction occurs in the presence of diffuse light, not a direct sunlight. However, in the presence of catalyst, such as the activated charcoal, the reaction take place even in the dark. Okay, and what are the role of the activated carbon? And the role of the activated carbon, it will absorb the hydrogen, and which increase the reactivity. Okay, means the activated carbon absorb hydrogen, and which increases the reactivity and form a what? Hydrogen chloride. Okay, so it is the first method by which you can obtain the hydrochloric acid. First, by the synthesis reaction, it is also called direct combination reaction. By second method, burning jet of hydrogen also burns in chlorine and forming a what? And forming a HCl. Okay, you know very well, hydrogen gas also found in the jet plane in the form of the fuel. When it will burns in the chlorine, then it will form water, hydrochloric acid, and it is a second method of preparation of hydrochloric acid. Get on the next method. Next method is your by heating metallic chloride. By heating metallic chloride with the concentrated H2SO4. It is a second method by which you can obtain the HCl. When metal chloride react with the concentrated sulfuric acid, then it will form salt and hydrochloric acid. It is what? NaCl. When NaCl is treated with concentrated H2SO4 and below the 200 degrees Celsius, reaction occurs at a below 200 degree Celsius, then it will form what? Sodium hydrogen sulfate and hydrochloric acid. Okay, and NaCl again react with the sulfuric acid greater than the 200 degree Celsius, not less than the 200 degrees Celsius. Then it will form the sodium sulfate and the hydrochloric acid. And similarly, copper chloride react with the sulfuric acid more than the 200 degrees Celsius heated, then it will form copper sulfate plus HCl. Okay, so please keep in mind, when the sodium chloride react with the H2SO4 at a less than the 200 degrees Celsius, then it will form the HCl, but byproduct form NaHSO4. Okay, but when this reaction occurs more than the 200 degrees Celsius, then it will form a major product HCl, but byproduct is what? Na2SO4. Clear everyone? Next method is your laboratory preparation of the HCl gas. So it is a laboratory method by which you can obtain the HCl gas in lab. In lab, when you will take or when you treated concentrated H2SO4 and the NaCl, here it is taken as a reactant, then it will form the what? HCl and plus Na2SO4, and the HCl is considered as main product, and whereas the Na2SO4 is it considered as a by-product. Okay, and the concentrated H2SO4 and the NaCl taken in the round bottom flask. Okay, NaCl H2SO4 when react with the less than the 200 degrees Celsius, then it will form NaHSO4 plus HCl. I have discussed in the previous slide. The reaction can occur up to the stage of the formation of Na2SO4 on heating above the 200 degrees Celsius. When you will heat the NaCl plus H2SO4 above than the 200 degrees Celsius, then it will form HCl plus Na2SO4. But when you will react less than the 200 degrees Celsius, then it will form NaHSO4 and the HCl. Yes. So when treated concentrated sulfuric acid and NaCl, so here it is what? NaCl taken in the round bottom flask. Okay, it is a flat bottom flask, and it is a what? Thistle funnel by which you can fill the H2SO4 means mix with NaCl. When NaCl and H2SO4 mix in the round flat bottom flask, then this reaction proceed in cold. So on heating, it will form what? HCl. It will form HCl gas, and by the delivery tube, HCl gas comes in the washer bottle. Okay, washer bottle, and containing the H2SO4. And when the HCl gas comes in washer bottle, and it also contains the H2SO4. And it is why it contains the H2SO4? Because of the, we will first of the HCl gas convert into the dry HCl gas. That's why I have taken the washer bottle containing H2SO4. So here H2SO4 is considered as the drying agent. Drying agent. When the HCl gas pass washer bottle containing H2SO4, then HCl gas will become what? Dry, and further it will goes into the another container, and it is a what? Dry HCl gas jar, and it is collected by the upward displacement of air in a gas jar. Always keep in mind that HCl gas collected by the upward displacement of air in a gas jar. I hope it is clear, understood. I have discussed this point. NaCl is cheap, that's why I preferred from the other metal chloride. Why I have taken the NaCl? Because of NaCl is a cheap, that's why I preferred from the other metal chloride. And the second point, concentrated nitric acid. Concentrated nitric acid is not used during the preparation of HCl because it is volatile. Volatile means easily converted into the gaseous form, and may volatilize out along with the H2. Okay, so first NaCl we will use, and the concentrated nitric acid is not used during the preparation of HCl because of the it is highly volatile in nature and may volatilize out along with the HCl. Okay, any problem? Next topic is your how you will collect, means the purify the HCl gas, means the purification of, next topic is your purification of HCl gas. It is dry by the passing through a concentrated H2SO4 and okay, concentrated H2SO4. So it is what? It is act as a drying agent. Water drying agent. And other drying agent not used. Means only you will use the which type of the drying agent? Concentrated H2SO4. Not use the like a P2O5 and the calcium oxide. You know very well P2O5 and the CaO also drying agent, but when you will this type of the drying agent, then it will react with the acid, means the P2O5 react with the HCl and the calcium oxide react with the HCl. That's why I not use a such type of the drying agent. Okay, When the P2O5 react with the HCl, then it will form phosphoryl chloride. Phosphoryl chloride. When the calcium oxide react with the HCl, then it will form the calcium chloride and the water. Okay? Or you know very well, collection of the HCl. HCl gas is collected by the downward delivery. Okay, downward delivery means the upward displacement of acid. It's a air. Okay, and it is 1.28 times the heavier than the air. Okay, and it is not collected over water. Why the HCl gas not collected over the water? Because of it is highly soluble in water. You know very well, all the acids are, generally all acids are soluble in water. Okay, that's why HCl is not collected over a water. Next topic is your, clear everyone, laboratory method of HCl. Next topic is your physical properties of HCl gas. Physical property of HCl gas. HCl is a colorless gas. Okay, pungent smell, and it has a sour taste and corrosive in nature. It irritates nose, throat and lungs, and it is heavier than air, near about the 1.28 or the 1.25 times denser than the air, and its BP minus 83 degrees Celsius, melting point minus 113 degrees Celsius. Okay, and the liquefaction of HCl means you can convert the HCl gas into HCl liquid. This process is called what? Liquefaction. So you can obtain HCl liquid at a high pressure, near about the 48 atm, and at a low temperature, 10 degrees Celsius, then it will liquefy to the colorless liquid, means the HCl gas liquefied into the colorless liquid. Okay, and you know very well, HCl is a highly soluble in water. I've discussed in the previous slide, and HCl being the polar covalent compound is also soluble in organic non-polar solvent, and the non-polar solvents such as acetone and toluene, means the HCl also soluble in the organic non-polar solvents such as acetone and toluene. You know very well the structure of acetone. You have learned the organic compounds acetone, ketone, and it is what? Toluene. It is the structure of CH3 methyl group is attached from the benzene ring directly attached. Okay, it is methyl group and it is a ketone. So I hope you understood the physical properties of HCl. Next topic is your experiment to demonstrate density. Experiment to demonstrate density. It is a experiment, you can say it is a type of activity by which you can demonstrate the density to show that the HCl gas is heavier than the air. How much? 1.25 times. 1.25 times. It can be proved by the pouring the gas in a jar with a burning candle. First of all, take in the water, a burning candle, okay, and the pouring the HCl gas in a jar with a burning candle. It is a burning candle and also contain a what? HCl gas. Which gas? HCl gas. The candle get extinguished because the HCl gas being a heavier occupies the lower portion of the jar and the forces air out of it. Means when you will take the water burning candle, okay, then the HCl gas is a heavier 1.25 times heavier than the air. Means the HCl gas accommodate bottom of the candle and it what? It outs the air from the bottom. Okay, HCl gas being heavier occupies the lower portion of the jar and forces the air out of it. Okay, and this experiment also proved that HCl gas is neither combustible nor supporter of the combustion. Means HCl gas is a not combustible gas and also not a what? Nor a supporter of combustion. नहीं ये जलता है और नहीं जलने में ये मदद करता है. Okay. Next topic is your experiment to demonstrate high solubility. Okay, high solubility of the HCl gas in a water. To show that HCl gas is highly soluble, okay, highly soluble in a water. It is demonstrated by the fountain experiment, by which you can demonstrate the HCl gas is highly soluble in water by the fountain experiment. It is a famous experiment, okay, for the demonstrate high solubility of HCl in water. First of all, I have take a what? Dry round bottom flask. It is a what? Dry round bottom flask filled with a dry HCl gas. Okay, and the second jet tube, and it is a what? It is a jet it is a jet tube, and it is what? Dropper. Okay, dropper few drops of the water. Then when you will press the dropper, okay, it is seen that the blue litmus solution enters the jet tube and with a great force forming a red fountain. Okay, so it is a what? Blue litmus solution and it is a round bottom flask and filled with the dry HCl gas. When you will push the dropper, means it will provide some what? Water. Okay, means the water combined with the HCl gas. When HCl gas mixed with the water and it will combine with a blue litmus solution. You know very well, litmus solution convert from blue to red. That's why when blue litmus solution combined with aqueous HCl, then it will give the spread like this, means the red fountain. That's why this reaction is famous, means experiment famous by the name fountain experiment. Clear everyone? Reason, as the water goes in the flask from the dropper, HCl gas present in the flask dissolve to its the high solubility, thereby the lowering the pressure inside. The outside pressure being higher pushes the blue litmus solution inside through the jet tube, and the blue litmus solution turns into red. Red due to the acidic nature of the HCl gas. HCl gas is a type of acid. Okay, and the acid converts the blue litmus paper into the red litmus paper. Due to the high solubility, HCl gas fumes in moist air, forming tiny droplets of HCl acid. Due to the high solubility, HCl gas fumes in the moist air, forming tiny droplets of the HCl acid. Okay, so clear everyone about the HCl. Okay, method of preparation of HCl I have discussed, and also I have discussed the laboratory method of the HCl and the demonstration of the highly solubility of the HCl in water. Okay, and acidic nature. And next topic is your chemical properties of HCl. Chemical properties of HCl. First, combustibility. First chemical property, combustibility. The HCl gas is neither combustible and nor a supporter of combustion. नहीं आपका ये कंबस्टेबल होता है और ना ही ये क्या करता है, कंबसन को सपोर्टर करता है. ओके, it does not burn, rather it extinguishes a burning splinter. ना ही ये सपोर्ट करता है और ना ही क्या करेगा, ये आपको जलेगा, बट इट एक्सटिंग्विशेस अ बर्निंग स्प्लिंटर को वो क्या कर देगा, बुझा देगा, एक्सटिंग्विशेस कर देगा. ओके, इट विल बी द एक्सटिंग्विशेस द बर्निंग स्प्लिंटर. तो विच गैस, HCl gas. Next, on the thermal dissociation of HCl, at more than the 500 degrees Celsius, HCl will dissociate into hydrogen and chlorine. Okay, more than the 500 degrees Celsius. Next, reaction with metal. When metal react with HCl gas, then it will form metal salt, and also it will give the hydrogen gas. Which gas? Hydrogen gas. And the metal chloride is a type of salt. When sodium react with the HCl, then it will form sodium chloride and also form hydrogen gas. Similarly, calcium react, it will form calcium chloride. Magnesium will form magnesium chloride. Zinc form zinc chloride, and iron form the iron chloride. Okay, in all the reaction, hydrogen is a what? Hydrogen also will form. Okay, next, reaction with ammonia. You know very well, ammonia is basic in nature, and it is what? HCl is a acidic in nature. You know very well, when acid react with base, then it will form salt. Then it will form what? Salt. Means ammonia ammonia react with the HCl, then it will form the ammonium chloride, and it is what? It is a type of salt. It is a ammonium chloride. Okay, and it will produce dense white fumes. Dense white fume. Yes. Next is your properties of HCl, means the nature of, you can say nature of HCl or the properties of HCl. You know, nature of the HCl is acidic, okay, acidic, and it is a strongly mineral acid. So HCl is a strongly mineral acid, and it also show all properties of acid. HCl shows the all the properties of acid, and you know very well, indicator is a substance, organic substance, by which you can identify the given solution is either acidic or basic or neutral. The litmus paper, you know very well, there are two types of litmus. One is the blue and the second is red. And the other example of the indicator, methyl orange and the phenolphthalein. The original color of the litmus paper is blue, and the original color of the indicator methyl orange is orange, and the original color of the phenolphthalein is colorless. But when your indicator is mixed with the HCl, blue litmus paper mixed with the acid, then the blue color converted into red. Means it shows the HCl is a acidic in nature. And similarly, when the methyl orange mixed with the HCl, then the color of the methyl orange from the orange converted into the pink. Means it will shows the HCl is acidic in nature. And last one is phenolphthalein, and the color of the phenolphthalein is colorless. When colorless of the phenolphthalein is mixed with the HCl, then it will give the convert into the, there is no any conversion of the color, means the it will be obtained similar, means the colorless, means also shows the HCl is a acidic in nature. So clear everyone, means HCl is a acidic in nature. You can identify this nature, acidic nature, by the using indicator, litmus paper, methyl orange and the phenolphthalein. Means litmus paper, blue litmus paper converted into the red in the presence of HCl, methyl orange converted into the pink in the presence of HCl, phenolphthalein colorless converted into the, not converted means the colorless. Okay. Next reaction is your action on metal. Action on metal. When metal react with the acid, then it will form salt plus hydrogen gas. Calcium chloride, magnesium chloride, zinc form the zinc chloride. Okay. And next reaction is your action on oxide and hydroxide. You know very well, there are the three types of the oxide. One is the acidic oxide, second is basic oxide, and third is amphoteric oxide. You know very well, amphoteric oxide means those oxide which we have as a acidic as well as basic in nature. Means the here discussing the which topic? HCl. You know very well the nature of the HCl is acidic in nature. Means the HCl only react with the basic oxide. Which type of oxide? basic oxide. It will not react with the acidic, not with the amphoteric. Amphoteric mein only it will react with the when it shows the basic nature, not with the acidic. Okay, means the acid when react with the basic oxide, then it will form the metallic chloride, means the it is a type of salt and plus water. Okay, HCl react with the magnesium oxide, then it will form magnesium chloride plus water. Zinc oxide react with the HCl, then it will form the zinc chloride and the water. And the FeO iron oxide react with the HCl, then it will form ferrous chloride. FeTO3 react with the HCl, then it will form FeCl3 ferric chloride. And the copper oxide react with the HCl, then it will form the copper chloride. Clear everyone? Means when acid HCl react with the basic oxide, then it will form salt and the water. Acid react, next reaction is your acid. When acid react with the base, then it will form salt and water. This reaction is called neutralization reaction. Why it is called the neutralization reaction? Because of the base neutralizes the effect of acid. That's why this reaction is called neutralization reaction. HCl react with the base NaOH, then it will form salt and water. When the calcium hydroxide react, then the calcium chloride plus water. Similarly, zinc hydroxide, then it will form zinc chloride. Copper hydroxide, then it will form the copper chloride plus hydroxide. All are the what? All are the base. Next reaction is your reaction with salt of the weaker acid. Reaction with a salt of the weaker acid. Weaker acid means Na2CO3. Na2CO3 is considered as a weaker acid. CaCO3 is also considered as salt of weaker acid. And it is also considered as calcium hydrogen carbonate. It is also a salt of the weaker acid. When the salt of the weaker acid react with the acid, then it will form salt and the water, and also form a what? Carbon dioxide. Okay, means when the reaction when HCl react with Na2CO3, CaCO3 or the NaCO3 and CHSO3, then it will form salt, water and the carbon dioxide. Next reaction is your reaction with the sulfite. When the sodium sulfite react with the acid, then it will form the what? Salt plus water and byproduct the plus also sulfur dioxide. Similarly, K2SO3, it will form the KClH2SO2, MgSO3, NHSO3 react with the HCl, then it will form salt, water and the sulfur dioxide. Clear? Means the acid, HCl acid react with the sulfide, then it will form salt, water and the sulfur dioxide. Next reaction is your metallic sulfide. Metallic sulfide react with the acid HCl, then it will form the metal chloride plus hydrogen sulfide, H2S. Okay, it is sodium sulfide, ferrous sulfide. Then when it react with the HCl, then it will form the salt and the hydrogen sulfide. Hydrogen sulfide is a gas, H2S. Next, acid. When acid react with the thiosulfate sulfate, then also it will form salt, water, sulfur dioxide, and also form a S, sulfur. Sulfur is considered as a yellow PPT. Okay, means the when acid react with the sulfide, then produce the sulfur dioxide. When they are treated with the hydrogen sulfide, metallic sulfide, then it will give the H2S sulfide, hydrogen sulfide gas. But when the thiosulfate, then also will form the salt, water and the sulfur dioxide, but also it will produce the yellow PPT of sulfur. Clear everyone? Next is your precipitation reaction. Precipitation reaction. Dilute HCl does not normally react with the nitrate. Means the always HCl react with the nitrate, means the concentrated HCl, not the dilute. Nitrates react with the acid, then it will form PPT, precipitate, and also it will form the nitric acid. Okay, when lead nitrate, okay, lead nitrate is treated with the HCl, then it will give the PPT. It is a PPT of the lead chloride, and the color of the lead chloride is white, and it also will form the nitric acid. And this lead chloride is PPT on heating, it will dissolve. It will dissolve on heating. Similarly, it is what? Mercuric nitrate. When they react with the HCl, then it will form the mercuric chloride. It is a white PPT and also form the what? Nitric acid. Similarly, when silver nitrate react with the HCl, then it will form the AgCl, silver chloride, as a white PPT and also form the nitric acid. And the AgCl will form the thicker cardi. Okay, means the AgCl on the giving the light into the AgCl, then it will form silver plus chlorine. And the silver powder, means the Ag gives the silver black powder. Okay, and AgCl, this AgCl not dissolve in the nitric acid, but AgCl react with the ammonium hydroxide, then it will form the complex compound. Complex compound are also called the coordination compound. So it is when the AgCl react with the ammonium hydroxide, then it will form the coordination compound. And the name of this compound is diamine. 2 times ammonia means diamine. It is silver first and it is what? Chloride. Okay, mean the when AgCl react with the ammonium hydroxide, then it will form the diamine, silver first, chloride, and it is a what? It is a type of the coordination compound or the complex compound. Clear everyone? Next is your reaction with the oxidizing agent. When oxidizing agent react with the hydrochloric acid, okay, then it will form the salt, water and the chlorine. For example, MnO2 is also oxidizing agent. When it is treated with the HCl, then it will form the manganese chloride. It is a type of salt, and the water and the chlorine gas. Lead oxide, similarly lead oxide react with the HCl, then it will form lead chloride plus water and chlorine. It is what? KMnO4, potassium permanganate. It is also oxidizing agent. When treated with the HCl, then it will form manganese chloride plus KCl. Both are considered as a salt, water and the chlorine gas. And it is what? Potassium dichromate. When potassium dichromate is react with the HCl, then it will form chromic chloride and plus KCl plus H2O and chlorine gas. So clear everyone? When the oxidizing agent react with the HCl gas, then it will form the salt, water and the chlorine gas. Okay? Next, hydrochloric acid. Hydrochloric acid. When HCl hydrogen chloride gas is mixed with the means dissolve in the water. Dissolve in a water. Then it will form. Then you know very well HCl gas will give the H plus and finally H plus combined with the water molecule, then it will form the hydronium ion. You know very well that all the acids give the H plus ion in the presence of water. In the presence of water. Okay? In the presence of water. So it is what? Hydrochloric acid means the hydronium. It is what? Hydronium ion. Okay. Then aqueous solution of HCl gas is known as HCl. So it is what? Hydronium ion and it is what? Hydrochloric acid and it is what? Hydrogen chloride gas. It exists in the gaseous form and it is exists in the liquid form, solution form. Dry HCl gas and the liquefied hydrogen chloride do not produce. Dry HCl gas and liquefied hydrogen chloride do not produce. H ion, H plus ion do not turns blue litmus paper into red because of the only H plus ion shows the convert into the blue litmus paper into the red when it will mix with the water. And the showing non-acidic character of the dry gas. And the next, do not means the HCl gas do not conduct the electricity. And what is aqua regia? Aqua regia is a mixture of the 1 part of the concentrated nitric acid and the 3 part of the concentrated HCl. When you will mix the nitric acid and the HCl, then it will form the nitrosyl chloride NOCl and the water and also produce the nascent chlorine. And this nascent chlorine is a very reactive in nature, highly reactive in nature. Metal such as Au and the platinum can be dissolved in the aqua regia which are not soluble in the other acid. Highly dissolving power of the aqua regia is due to the nascent chlorine. Means that this chlorine reaction, nascent chlorine is responsible for the high dissolving power of the any substance, means the Au or platinum. So Au react with the nascent chlorine, then it will form the AuCl3, and platinum react with the nascent chlorine, then it will form the PtCl4. Okay, so clear everyone? The aqua regia is a mixture of 1 part of the nitric acid and 3 part of the HCl. Next topic is your uses of hydrochloric acid. General uses of the HCl in laboratory as a reagent and for the preparation of the aqua regia. I have discussed in the previous slide. Aquaresia is the mixture of the concentrated HCl and the nitric acid. Second, industrial uses in the manufacture of the chlorine and the chloride, okay, dyes, drugs, paints, and the photographic chemicals, and the next glucose from the starch. So the different uses of the HCl, hydrochloride acid, in the general laboratory, and the second is industrial, as the formation of the chlorine and the chloride and the dyes, drugs, paints, and the photographic chemicals, and also glucose from the starch. In industry, to pickle steel, okay, to remove the rust from the iron sheet, in the extraction of the glue from the bones, in all the cases we will use the what? HCl gas, hydrochloric acid. And also use in the medicine, dilute HCl is the prescribed to the patient with a decreased activity of their gastric juices. And HCl help in the digestion of protein. Okay, I hope everyone you understand the topic. Which topic? Your topic HCl. Okay, so please note in the make the notes. Okay, and next time we will discuss the next chapter, chapter number 8. Okay.